Welcome to 11.5, Probability with the Fundamental Counting Principle, Permutations, and Combinations. So again, now we're going to look at the probability using these different aspects. Okay, so the first thing we're going to talk about is computing probabilities with permutations. So remember, permutations are when order, in fact, matters. So remember those dad jokes that we talked about in a previous video. All right, you can read through those. And what we want to do is we want to look at this first example where it says, let each joke be written on one of 6 cards, which are randomly drawn 1 card at a time. The order in which the cards are drawn determines the order in which the jokes are delivered. What is the probability? So I see that word probability, that a joke about something with the human form is told first, and a joke involving food is told last. So I want a human joke first, and I want a food joke last. So let's just go through and see how many jokes deal with humans, okay? So we've got this scarecrow. We can say, well, all right, that's dealing with kind of a human. Let's just say it is. And then we've got, let's just say skeleton, okay, is the other human joke. What about food? Well, let's just go ahead and say nacho cheese joke. All right, that's food. And even though this last one deals with Beethoven, it also deals with the banana. So we'll consider that a food joke. Okay, so since we want probability, we're looking at a fraction. Okay, so let's kind of break this down. I'm going to zoom in. All right, so we want to know the probability of a human joke first and a food joke last. So when we're setting up our probability, we want to compare the number of permutations with human joke first and food joke last, and we can put that all over the total number of possible permutations. Okay, so let's look at our numerator. The human joke is first, food joke is last. So remember, we've got 6 slots, okay? So how many different jokes do I have that are humans? 2, all right? 2 jokes that are humans. We had 2 jokes that were food. So I need my human joke first, my food joke last. So then how do we fill out the rest? Well, the rest I'm going to have 4 jokes left to choose from. So in this first slot, I've got 4 jokes to choose from. In the next one, I've got 3, then 2, then 1. So this portion, this pink portion, is our permutation, okay? The other portion is that fundamental counting principle. All right, so now that takes care of our numerator. Now again, we have 2, our permutation where order matters. I can't repeat any jokes, so it's 4P4 times 2, our last joke. All right. Now let's talk about the total number of possible permutations. Okay, so let's think about it. I have 6 jokes that need to fill 6 spots. So the number of total possible permutations is going to be 6 choose or 6P6. Okay, so the number of permutations with food first, human first and food last is this 2 times our permutation of 4P4 times 2. And we put that all over the total number of possible permutations. So now all we need to do is clean this up. Okay? And when we do, we still have 2. 4P4 is 24 times 2. 6P6 is 720. Cleaning everything up, we get our final answer of 2 out of 15 is the probability to do a human joke first and a food joke last. Now let's take a look at some probabilities dealing with combinations. Remember, combinations are where order does not matter, okay? It does not matter. So let's look at this checkpoint 2. Hitting the jackpot in Powerball is not the only way to win a monetary prize. For example, a minimum award of $10,000 is given to a player who correctly matches 4 of the 5 numbers drawn from the 59 white balls and the 1 number drawn from 35 red balls. Find the probability of winning the consolation prize. Express the answer as a fraction and as a decimal, correct to 9 places. Okay, so let's take a look at this setup here. So we want to know what's the probability of winning this consolation prize. So we take a look and we say, well, what are the number of ways we can win over the total number of possible combinations? Okay, it doesn't matter the order in which these balls are chosen, so long as my numbers match what's pulled out of them. So how many ways can we win? Well, there's only one way. You only have one ticket with certain numbers on it. So there's only one way. All right, how do we figure out the total number possible combinations? Well, we're choosing 4 white balls and we need 1 red ball, okay? So from the white balls, there's a total of 59. We only need to match 4. So 59C4. There's only 1 red ball, so there's only 35 different ways we can choose a red ball. So we're going to multiply those together to get the total number of possible combinations. So when we do that, we have 1 over 59C4 times 35. If we were to use our calculator, 59C4 times 35, we're going to get this really big number, 15,929,410. So we have 1 in 15,929,410 possible, or that's our probability. Not looking so good. And if we wrote that as a decimal, this is what we would get. I want you to try checkpoint 3 on your own. I'll help you with the setup and you finish it off. Let's suppose a club consists of 6 men and 4 women. 3 members are selected at random to attend a conference. Find the probability that the selected group consists of 3 men. So you have to ask yourself, does order matter? Do I care which order the men are selected, or do I just need the 3 men selected? See if you can do the setup. Then let's check let's compare answers. So we should set it up this way. The probability of 3 men. So I need the number of ways of selecting the 3 men over the total number of possible combinations. So how do we go ahead and possibly choose 3 men? So you have to ask yourself, well, how many men are there to choose from and how many do you want? Over the total number of combinations. How many people are there total and how many people are you choosing? Okay, so give it a thought and come back. Okay, so hopefully you recognized there's 6 men and we need 3. I don't care the order. So 6C3 is the ways of selecting men. How many total combinations? Well, we have 6 men and 4 women, so we have 10 people total, and we're just choosing 3 people. So it's 10C3 is the total number of ways we can choose 3 people from this group. If we go ahead and plug into our calculator, we will get 20 over 120, and this simplifies simply to be 1 over 6. Try part B on your own. What's the probability to select 2 men and 1 woman from this group? Okay, so see if you can get this set up, and then go through, finish the problem, and we'll check answers. This was a little different because our numerator dealt with men and women. So I wanted to know the probability of 2 men and 1 woman. Well, the probability of selecting 2 men is I have 6 men total, and I want to choose 2. It doesn't matter the order. So 6C2 is for the men. Now, I only want 1 woman, but there are 4 to choose from. So 4C1. And we're going to multiply these 2 together because that's the fundamental counting principle. What's the total number of possible combinations? Again, I have 10 total people to select from, and I only want 3. So 10C3 is still my denominator, my total number of combinations. So now we can just use our calculator. 6C2 is 15, 4C1 is 4, and 10C3 is still 120. 15 times 4 is where we get 60. 60 over 120 comes out to be 1/2. Or we could even say 50%. So what's the probability of selecting 2 men and 1 woman? Is 1 out of 2 chances. If you have questions on this, make sure you ask in class next time we see each other.